Hey guys, welcome back. Today we're going to be focusing on fractions, and how they're represented in different forms, okay? So you were going to see this probably a lot in 6th grade where they'll give us a question or a problem solving question and we have to represent it as a fraction, as an expression, and I call this box form and also as a decimal. So they'll give you guys like a problem solving question like this and we have to represent the fraction in all four different forms. So let's go ahead and get started. It says Stacy wants to share 10 boxes of candies equally amongst her and her 6 friends. How do we represent the part of the boxes that they will each receive in all forms? So the very first thing we want to ask ourselves is what's important? Well, we know that Stacy wants to share. She wants to share 10 boxes of candies, so that's important there, amongst her and her 6 friends. And so I want to ask you guys, how many people are there in total? If it's her and her 6 friends, we got to count her. We got to count Stacy. That's a total of 7 people. And what does Stacy want to do? She wants to share her 10 boxes of candy. Okay? So we got to represent this in all 4 different forms. And one of the most difficult parts or things the students struggle with is knowing what goes in the top and what goes in the bottom in a fraction. So I always remind my students, I tell them, I want you guys to ask yourself this question: what are we dividing into equal parts? So I want to ask you guys that same question. What are we dividing into equal parts? Are we going to divide the 10 boxes of candies into equal parts and share those? Or are we going to divide the 7 people into equal parts and share them? And yeah, this doesn't make sense, right? We're going to take the candies and we're going to divide the candies into equal parts because that's what we want to share. And I put here what is being divided into equal parts goes on top of the fraction. So when we create a fraction, whatever's being divided into equal parts, that's going to go on the top. So we said, what is being divided into equal parts? The 10 boxes of candies or the 7 people? We're dividing the 10 boxes of candies, so that's going to go in the top. And the other number is going to go on the bottom. Again, why did this go on the top? Because that's what we're dividing into equal parts. We're dividing the boxes of candies into equal parts. This is so important. If you flip if you were to flip this fraction upside down, if you have the 7 in the top, the 10 in the bottom, your answer would be wrong. When we're representing the fraction in different forms, you got to remember order is super important. So start off by asking yourself this question: what is being divided into equal parts? Whatever is being divided into equal parts, that goes in the top. And in this example, we have the bigger number that's in the top. Sometimes there'll be a number that's smaller than the denominator. So just happen to work this way in this example, but sometimes you don't always put the bigger number in the top. That's why you have to ask yourself the question: what is being divided into equal parts? Okay, so now let's represent as an expression. Again, order is so important. If you flip these backwards, you're probably going to get your answer wrong. And that might be one of your answer choices. That's how they're going to try to trick you. So it says here, what is being divided into equal parts goes on top of the fraction, and what is in the top of the fraction, that goes first in the expression. So since we have the 10 in the top of the fraction, then when we write out our expression, we're going to put the 10 first. Again, the 10 sets in the top, that is what goes first in the expression. Our order is very important. So let's put 10 divided by 7. These mean the same thing, okay? But the order is so important. If I were to put 7 divided by 10, this would be wrong. It's not 7 divided by 10. We got to put the top number goes first. Whatever is being divided into equal parts, it goes in the top. And once we have found our fraction, whatever's in the top, that is what comes first in our expression. What's in the top goes first. Doesn't go second, it goes first, okay? And now we got to represent this in box form. So 10 over 7 is the same as 10 divided by 7. So what's going to go inside the box? So the top number goes inside the box. We could think of a cowboy and a horse. And in one of my other videos, I explained that. We could think of the cowboy being inside of the house. Or we could think of I've heard of the teachers teach it this way: top dog goes in the house. So the top number goes in the box and the bottom one goes outside. Now again, the order is so important. If I were to do this, my answer will be wrong. This is 7 divided by 10. Okay? And right here we're representing 10 divided by 7. And the last thing is you might find your answer in decimal form. So let's go ahead and divide 10 by 7 and change this to a decimal. So how many groups of 7 go into 10? Well, it's one group. 7 times 1, that's 7. So 10 minus 7, that's 3. Now we're going to put a decimal since we can no longer divide. And we're going to bring down a 0. How many groups of 7 go into 30? That would be 4. And we're running a little bit out of space here, but 30 minus 28, that's going to be equal to 2. Bring down the last 0. And 7 times 2, that's 14. And this will probably keep on going on forever. I tell my students it's okay if they stop in the hundreds place, and that's really up to your teacher. But in decimal form, 10 over 7, that would be the same as 1.42. And again, it's very important that we begin by asking ourselves the question, what are we dividing into equal parts? And here we're dividing the box of candy into equal parts, and whatever's being divided into equal parts, that's what goes in the top. Whatever's in the top of the fraction, that is what goes first in the expression. See, whatever's in the top goes first in the expression. You guys see? Top goes first. And in the box, whatever's in the top, that goes inside of the box or in the house. And then we could change this to a decimal. And this is representing a fraction in all 4 different forms. So 10 over 7 is the same as 10 divided by 7 as an expression, is the same as 10 in the box and 7 outside, and that is the same as 1.42. Again, order is very important. I can't flip these backwards or my answer is going to be wrong. Okay? Well, thank you very much. Hope this helps. See you guys next time.